Welcome to Developing Graphics Frameworks with Python and OpenGL. Part 4, Creating Windows with Pygame. In a previous video, we learned about the graphics pipeline and the different stages, the first stage being the application stage. In this video, we'll start to put some of that theoretical knowledge and turn that into practical knowledge by creating that window. We'll set that up using Pygame, and it will receive data from a frame buffer on the GPU, and we'll start preparing the framework to display the graphics that we're going to create throughout this video series. First, we need to learn a little bit about the application lifecycle. Every interactive, graphics-based animated application will require this set of stages. First, every application has a startup stage where we'll create our objects, we'll initialize values, and we'll load any external files. And then our application will enter something called the main loop. And this is going to repeat continuously. Since we're doing a desktop-based application, we'll aim for 60 frames per second as long as the application is running. And this will consist of 3 sub-stages. The sub-stages are first going to be processing input, right? So first, we have to check to see if the user has performed any action that sends data to the computer. They might have pressed some keys on the keyboard or clicked some mouse buttons. We might want to respond to that input. That input might include quitting the program, in which case we'll proceed to the shutdown stage. But if the user hasn't signaled a quit, we'll move on to the update stage, where we'll change any values of in-application variables or objects. We might apply some transformations. We might run some algorithms such as physics simulation or collision detection. And then once we're done, we'll go to the render stage where we create the graphics that are displayed on the screen. And that's the stage which involves the vertex shader and the fragment shader, and a lot of material we'll discuss later on. After the render stage, we loop back and we process input, and we continue this process again and again until the user signals a quit, at which point we'll stop checking for user input and we'll close the application windows. And so our first goal is going to be to create a class in Python, which we'll call the base class, which will implement this framework for us, including some very basic input processing. And we won't really display graphics yet. The goal of this first video is just to get a window up and running. So first I'm going to go ahead and start up Sublime Text. So here's Sublime Text, and we're ready to begin. So as we write code, we're going to keep a lot of software engineering principles in mind. We want our code base to be organized. We're going to want it to be reusable. We want the classes to be extendable. So to start off, you'll need to create some kind of a main folder on your computer system where you're going to store all your projects. I've created a folder on my desktop called Python Graphics. And again, one of the things I like about Sublime Text is you can keep track of all your folder files very easily within the application instead of having kind of a separate file manager window open side by side. Once you create your folder, you can go ahead and open Sublime Text. And I start off by actually going to Open Folder. I've opened my folder, which I've called Python Graphics. And we're ready to start writing some code. Now, the reusable components, we'll keep those in separate folders. So the first thing I'm going to do within the Python Graphics folder, I'm going to create a subfolder called Core, which will contain our core code. So I can do that within Sublime by right-clicking and choose New Folder called Core. You see it appears right here. I'm going to go ahead and in that file, in that folder Core, I'm going to start putting some code in there. And if you're using something other than Sublime Text, you can of course do this with your file manager program and then come back to your application later on. Now, core is an example of something in Python called a package. Just like NumPy or Pygame, a package is a collection of related modules. module is a file containing Python code. Now, for Python to recognize this folder, this core folder, as a package, we need to create an initialization file. So within the core folder, I'm going to right click and I'd like to make a new file. And this file is going to be a blank file, but one that Python expects to find, called the initialization file. So I'm going to go ahead and save this file. It's automatically in my core. I'm going to save it with a file name, which may sound a little bit strange, underscore underscore init underscore underscore .py. And just go ahead and save that. That's just a signal to Python that all the code in this folder constitutes part of a package. All right, now if I click to open the core folder, I can see that I have an init.py in there. Now next I'm going to create my base module, which will contain the base class, which I'll use in every application created throughout this video series. So again, in the core folder, I'm going to right click that and create a new file. And this one, I'll save it right away. This one I'm going to call base.py. I'm going to say base with a lowercase b to distinguish it from the class base, which we'll create in this file. All right, so let's see. Within this file, I'd like you to go ahead and you can follow along. If you need to, feel free to pause. This is a video after all. We're going to just start writing some code. And first I'll talk a little bit about it as I go along, and then I'll kind of stop and review and discuss a little bit more. We're going to use the Pygame module, so I'm going to import Pygame. I'm also going to use import sys, and that's going to be for terminating the application once it runs. I'm going to create a new class called base with a capital B, and I just like to write the, in parentheses, object that indicates that it extends the base object class. Within each class we need a constructor, so I'm going to define the constructor function, and again it's def underscore underscore init underscore underscore, and this is a class method, so in parentheses say self. And what do I want to do? I'm always going to use lots and lots of comments in my code. It's an important thing to do. The first step is going to be to initialize all the Pygame modules, and we'll do that with pygame.init. Next, I'd like to set the width and the height of the window. And I'm actually going to store that in a variable. I'll call that screen size. I'm going to store that in a tuple. I like it 512 by 512. OpenGL really prefers textures and images whose size is a power of 2. That'll be big enough for most of the things we'll make at first. All right. Next, the Pygame window, we need to tell it what kind of rendering modes we want it to use. So next I'm going to indicate some rendering options. Let's see, I'll store this in something called display flags. And I'm going to use two things. These are stored as constants within the Pygame module. First, pygame.doublebuff. That's a technique called double buffering, which I'll explain in a minute, combined with pygame.opengl. And that signals that the window is going to get its contents from the frame buffer once we've got that set up. All right, next I want to create and display the window. To do this, there's a function in Pygame, but I also want to be able to access this again later on. So I'm going to store this in a self variable. So let's say self.screen equals pygame.display.set_mode. And the two things I'm going to set are screen size and also display flags. And again, I like to make the code readable, so I'm going to separate that out. Let me move this up so you can see it on screen. I always like my code to be as readable as possible. That's why I like to store these different rendering options and things in different variables. Right, so this line of code activates and displays the window for us. Next, I'd like to set the text which appears in the title bar of the window. Let's see, so I'll do that with, let's see, pygame.display.set_caption. I'll just say graphics window. And you can have that display whatever text you want. All right. I also want to, I should add a comment to that too, set the text that appears in the title bar of the window. All right. Next, I'm going to have a variable which determines whether or not the application is running. And so this determines if the main loop is still active. And that's going to be self.running equals true, capital T. And finally, Pygame has a great class called clock, which can manage a lot of the time-related operations. So to manage time-related data and operations, I'll use self.clock. So I'll define that variable, and I'll initialize it with pygame.time.clock. Cool. All right. So that's our initialization method, or not our, yeah, that's the init. That's like the constructor of the class. Now remember, we're going to have other classes which extend this base class. And so I want to allow them to kind of run their own initialization code. All right, so I'm going to create kind of like an abstract method which will be implemented by the extending class. So I'm defining a new function. So notice the indentation level. I've gone back out one level of indentation. I'm going to define a method called initialize. It's an instance method, so I need the self argument. I'm going to say pass, because I'm not going to write the code for that method here. The code will be written in any extending classes. Similarly, within the application lifecycle, you might remember that there is a step for processing input and a step for updating. Every application will have its own variables it might want to update. So again, I'm going to create another function which I'd like to implement by the extending class. I'm going to say that's def update. It's going to be the name of that function. And again, I'm going to pass. That'll be extended by whatever class updates it. All right. Now here is going to be the main loop for the application. It's going to be within this method called run. And I'm going to again add some comments where I refer to the different stages in the life cycle of an application. First we have the startup stage. Right, so I'm going to ask the extending function to run its initialize function. And next comes the main loop. Right, and this is going to happen while the application is running, and that's according to the Boolean variable self.running. And so while the application is running, I've got three stages I want to do. First, I'd like to process input, and I'm going to handle that with a separate class because I want my code to be modular as well. So that'll be a to-do. We'll do that in a minute. The next stage is going to be the update stage. Right, and again, I'm going to defer to the update method written by any class which extends this. And finally, the render stage. Right, so whatever image is currently in memory, I'd like to display that on screen. So we'll display an image on the screen. And that's going to happen with the command pygame.display.flip. Again, this has to do with the double buffering technique, which we'll talk about in more detail in just a moment. Now, this is a very simple program which can run at a speed much greater than 60 frames per second. So we're actually going to use the clock object here to slow it down a little bit. So I'm going to pause if necessary to achieve 60 frames per second. Right, and we do that with the clock object, self.clock. Tick is a command which is going to slow it down to 60 frames per second. All right, once that's done, all of this code right here is within the while loop, right? While the main loop is running, we have these 3 stages. And then whenever running gets set to false, right, at that point, it'll be time for the shutdown stage. And so notice the indentation level. I'm going back in a level for shutdown, in which case I'm going to say Pygame quit. That'll go ahead and close the Pygame window, but I'd like to stop anything else which is running as well. And that's where we use the system.exit. Right, and that'll completely shut down our application. All right, so that's kind of our base class. We'll add a few things to it over the course of this video series, but just a few comments on this code before we continue. I mentioned that the screen size right here, I like to use powers of 2, but you can change these numbers as you wish. When we set the display flags, this little pipe character, right, on my keyboard it's right above the enter key. It's called bitwise OR. It kind of does like a bitwise, well, it does bitwise OR. It's a way of combining the bits of these 2 constants to get a new constant which is stored in display flags. Right, so you can think of this as combining the 2 different constants. The double buff, that's short for something called double buffering, and that's a rendering technique which uses, as you might have guessed, 2 image buffers. The idea is that the pixel data from one buffer is going to be displayed on the screen while the GPU is writing data to the other image buffer in memory. And then when the new image is ready, the command flip, which occurs later on, that will switch between the 2 buffers, and that way you'll never be operating or drawing graphics to the window directly. Right? All the rendering operations happen in memory, and this is important to eliminate this kind of visual glitch called screen tearing. You might not have seen it before, but this happens when the pixels from a partially updated buffer are displayed on screen, and if the rendering cycle isn't in sync with the refresh rate of your monitor. So double buffering it eliminates a problem that hopefully you never see. And I briefly mentioned the clock object that's used. Has lots of uses. It can keep track of how much time has passed since a previous function call has happened. So we'll use that for timing operations later on. It can state how many times a loop has run within a second, so it can calculate and display frames per second pretty easily. Right now we're using the tick function later on in the main game loop to slow it down to 60 frames per second. If we didn't do that, the program might run at some ridiculous speed. It might go for like 500 frames per second, which would eat up 100% of your CPU and grind everything else to a halt. So that's why this command is going to be very important. Initialize and update we'll fill in later. And then, let's see, then the run function, we'll call the run function by the classes which extend this, which we'll write a little bit later. Okay, the next step is going to be to do some really basic input processing. At the very least, you need to be able to quit out of your application, right? So we need something in process input. To keep our code base modular, we're going to create a separate class which will handle the input functionality for us. So again, I'm going to go back to my core folder. I'm going to right click and make a new file. And this one I'll save right away. I'm going to call this input.py. Again, I like to call my files, I like to start them off with a lowercase letter and then the classes with the capital letter. I think that helps the import statements read a little bit more clearly, as we'll see in a moment. So go ahead and save this as, again, lowercase input.py. And the code for this, again, I'm going to need some things from Pygame. So I'll start off with importing Pygame, as before. And the name of this class is input. And as always, I need my initialization function. So def underscore underscore init underscore underscore self colon. And really the question for input right now is, has the user quit the application? Right, so I'm going to go ahead and create a variable to store that information in input. First, the comment, has the user quit the application? And I'll store that in self.quit. And initially, let's assume the user hasn't quit. All right, within the input class, I'm going to define a function called update, not to be confused with the other update function. Update is checking if anything has been pressed recently. So I'm going to define another function called update. And the goal of this is going to be to iterate over all the user input events. Right, so that includes like keyboard and mouse events, to see what has occurred or that have occurred since the last time events were checked. Right, whenever you press some kind of a key when Pygame is running, it kind of stores that up in a queue, and until you check it, that information is stored. So basically, we're checking the Pygame queue here of different input events. And we'll do that with a simple for loop for each event in the list of events. So pygame.event.get. So the quit event occurs or is triggered by clicking the button in the corner of the application window to close the window. Right, so to check that, we'll see if event.type, checking for equality, so double equals pygame.quit all in capitals. And if that's true, then we'll just set the input class variable quit to true as well. So we can kind of query that at a later time. So if that's true, self.quit equals true with a capital T. And that's it. Right now the class is really going to only monitor for kind of input quit type events. Later on, we're going to monitor for keyboard style events, but the first goal is to be able to close the window. All right, so that's it for the input class. Be sure to save your code. And the little circle icon there indicates that there's unsaved changes. So I'll save that. Now that we have this nice little input class, right, we're going to go ahead and go back to the base class. I'm going to scroll all the way up to the top of the base class, and now we're going to import the class that you just wrote. So I'm going to import, but I'm going to import from a module that we've defined. So I'm going to say from core.input, I want to import the input class. Oh, and that's with a capital I. I don't want it to autocorrect. No, don't autocorrect. That really is capital I input. All right. So a couple important things about this statement right here. The way this is written, this assumes that the application is going to be sitting in kind of the base directory, and the application is going to look in the core directory for a file named input.py with a capital I. And by importing just input like this, that allows us to create an input object fairly easily. Right? So to create an instance of this class, of this input class, I'm going to do that in my constructor function. Maybe I'll put this down here at the end of the function. Right? So in order to manage user input, let's go ahead and create an input object. I'll call it self.input equals input. All right, so that initializes an instance of the class for us. And now let's scroll down a little bit to the run function. Let's go down to that empty process input area. All right, so first I want to add self.input.update. Now we just wrote this function. Update within the input class will check to see what keys have been recently pressed, or in this case, if the X has been checked. And so after processing the input, I can say if self.input.quit, right, that's a Boolean expression, quit, so I'm checking if it's true or false. If it's true, I want to set self.running to false. Right, and so it'll update and render one more time, and then the next time it gets back to the while loop condition, it will quit out. So after quitting, we will have one more kind of cycle of the main loop. All right, this enables the user to stop the application. Fantastic. All right, so let's go ahead and save this. And now we're going to write our first application class. Right, so this is going to be in our root directory, right, that sits kind of below core. So I'm going to go back down to my Python graphics folder, or whatever you named your core folder. I'm going to right-click and create a new file. And let's see, I'm going to save this one right away. I'm going to save this as, I'll call it test, what is this, video 4? I'll call this test04.py. All right. So first, I'm going to extend the base class, so I need to import the base class. From the file, the core directory, the file named base, I want to import the base class. Oops, and I need to make sure that that does not autocorrect to a lowercase b. And now I'm going to create a class called test. I'm going to call all my classes test. And this extends the base class. All right. Now within this class, I don't need to do too much. Right? The goal is not to draw any amazing 3D graphics yet. The goal is to get a window up and running. So the things that I have to create, remember within the base class there were two functions that I passed on. Right, so I'm back in base. Right, we defined an initialize function, and we defined an update function, but we didn't put in any code there. So I'm going to go ahead and, in my test class, I'm going to define initialize. And I'll just print a message to let us know that everything is actually started. I'll print the message maybe initializing program. And update, there's really nothing to do for update again. It seems kind of silly to write pass again, but it's a good habit to keep writing these functions. Right? All our applications should involve initializing and updating. Now, once that's done, that defines a class, but it doesn't actually start the application yet. Right? So within this application, not only do we define this class, but I want to create an instance of this class. So create an instance of this class and run the program. Right, so I'll do that in one line. First, I'm not going to save this in a variable. I'm just going to initialize the function, or initialize the class called test. Then I'll run the run function. So if this works, fingers crossed, but if it works, a graphics window should appear, and also the console should be activated, and it should print this message, initializing program. So we'll go ahead and save that. And again, to run a Python file, you can either press Control B or go down to the Tools menu and choose Build. Hey, and a bunch of great things just happened. So first, you'll notice right here, I've got a window. I've got a Pygame window. It's got the Pygame snake icon in the corner. And the text is kind of small. I apologize. It's probably hard to read, but on your own system, you'll see that it says graphics window. It's 512 pixels by 512 pixels, just as we asked. And also, the console opened up, and it says, hello from the Pygame community. Hello, Pygame community. And initializing program. So, hey, everything's working just as we had hoped. So congratulations on writing your first application. We haven't used the GPU yet, right? It's trying, well, we're accessing the GPU, but there's nothing being rendered. It's basically an empty frame buffer. So in the next video, we're going to start to write some programs. We're actually going to get something interesting to appear in this graphics window.